All right, let's look at the homework 13.3, problem number 10. All right, so we want to find the equations of the osculating circles of the ellipse 9x squared plus 4y squared is equal to 36 at a couple points 2, 0 and 0, 3. The osculating circles are the circles that touches the curve and having the same curvature as the given curve. All right, so let's try to find that. All right, so first we have to find the curvature. So let's see, I'm going to parameterize this ellipse here. All right, so I'm going to rewrite it into a standard equation here. So I'm going to divide this guy through by 36. All right, so you have x squared over, all right, 9 and 36 cancel out, so you get 4. 4 is 2 squared, so 2 squared on the bottom. All right, and let's see, 4 divided by 36 cancel out, so you have a 9, so you have 3 squared on the bottom. So you have a y squared over 3 squared is equal to 1. Right, that's in standard form. So if you want to draw a picture, so you can see that this is going to be, right, this is going to be an ellipse. Let's see, so we know that on the x-axis it's positive 2 and negative 2. And the y-axis is going to be 3. And we have, oops. All right, negative 3. All right, then so the ellipse is going to look something like this. All right, then we want to parameterize this. So what we can do is we can parameterize this as, let's see, r of t is going to be, all right, so 2 times cosine of t, and 3 times sine of t, and this is on the xy plane, so z is going to be 0. All right, so let's compute the curvature. All right, so you have, we need the first derivative, which is going to be negative 2 sine of t, and 3 cosine of t. All right, then we need another derivative, so second derivative. This is going to be negative 2 cosine of t, and a negative 3 sine of t. All right, so we can find the cross product. So first derivative cross product with the second derivative. All right, so this is going to be, all right, so here this times that times that, so it's 0. And this times that times that, 0. Right, because it's going to be a circle in the xy plane, so the cross product is going to be actually only in the z direction, so it makes sense. So you have, so this times that is a 6 sine squared minus this times that is negative, so negative 6 cosine squared of t. Right, so this is just going to be 6, right? So this going to give you 0, 0, 6. All right, so we can find a curvature. So curvature function is going to be, remember that this is just the magnitude of r prime cross product with r double prime, and divided by magnitude of r prime and cubed, right? So this is going to be, numerator is easy because it's only one component, so the magnitude would be just the absolute value of the component. So it's going to be 6. And on the bottom, all right, so we have to compute this. So this is a first derivative, so a magnitude would be square root of 4 sine squared of t, and plus 9 cosine squared of t. All right, so we got that. Then we just need to cube that. All right, so we have that. All right, so let's look at the point. So first point is 2, 0. So 2, 0 is sitting right here. And as you can see, this is where t is equal to 0. All right, so let's find the curvature there. So curvature when t is equal to 0 would be, all right, 6 over, all right, I'm going to put 0 there, so that's 0. So cosine of 0 is 1, so square root of 9 is 3, 3 cubed. So you have 3 cubed. All right, so that's the same thing as one of the 3's cancel out, so it's going to be 2 over 9. All right, so if curvature is 2 over 9, remember that corresponding circle has a radius, which is a reciprocal of that. So it's going to be r is equal to 9 over 2. All right, so we want to have a circle that touches this 2, 0, and the radius is 9 over 2. All right, so 9 over 2, so let's see, 2 is, so we have to subtract the 9 over 2 from 4 over 2. So it's going to go over to, let's see, 2 minus 9 over 2 would be negative 5 over 2. So what would that be? So it's going to be sitting somewhere around here. So negative 5 over 2. All right, then with the center here, then we draw a circle. So it's going to look so somewhat like that. Right? I might not be able to draw the entire circle, but the circle is going to probably look like that. All right, so equation of the circle is fairly easy because center is sitting at the negative 5 over 2, and we already know the radius. So equation is going to be, and so it's going to be x, right, center at the negative 5 over 2, so plus 5 over 2 squared, plus there's no shifting in y direction, and the radius is 9 over 2, so 81 over 4. All right, so let's type this in first. So we have equation, it's going to be x plus 5 over 2 squared plus y squared is equal to 81 over 4. All right, so let's check the answer. So I'm going to go down here, submit for testing. All right, it came back and looks like we got the first oscillating circle. All right, so let's find the second one. All right, so only difference is we are talking about a different point. It's at 0, 3. Now we're talking about this point. All right, this is where t is equal to pi over 2. Right, so we just have to find the corresponding curvature. So curvature at t equals pi over 2 would be, all right, 6 on top. That doesn't change. All right, so sine of pi over 2 is 1, and the cosine of pi over 2 is 0. So it's going to be square root of 4, it's 2, and a cube it. So it's going to be 6 over 8, which is going to be 3 over 4. Right? So this tells you that the radius of the oscillating circle is going to be a reciprocal of that curvature, which is 4 over 3. All right? So 4 over 3, so you start from 3 and you have to come down 4 over 3. So it's going to be, let's see, 3 is 9 over 3, and you're subtracting 4 over 3, so it's going to be 5 over 3. So, and probably something like that. And this is a 5 over 3. Then we have a circle, which looks like that. All right, so the equation is fairly easy. So there's no movement in x direction, so no shifting, so just x squared. But this is going to be y minus, let's see, we're moving to 5/3 squared, and the radius is 4/3, so 16 over 9. All right, so let's type it in, 5/3. All right. All right, so we have x squared plus y minus 5/3 and squared is equal to, I forgot the radius. Radius is 16 over, the 4 over 3, so 16 over 9. All right. So let's check the answer. Submit for testing. All right, I came back and looks like we got this one correctly. All right, so then after that, we just have to choose the correct picture. All right, so it looks like, let's see, first one and the third one has the correct ellipse. And the correct picture for these oscillating circle would be this one right here, the third one. So I'm going to check that and then submit for testing. All right, it came back and looks like we got the correct picture as well. All right, that's it. I hope that this was clear.